Imagine a vast open field in the waning light of an English summer evening, the year 1894. A colossal latticework of steel and wood stretches out across the landscape, its frame dwarfing the scattered trees nearby. At its heart sits an immense contraption shaped vaguely like a wingspan, a testament to human ambition and the march of industrial might. This is Hiram Maxim's flying machine, a steam-powered behemoth born from the restless mind of an inventor best known for revolutionizing firearms. Yet despite the hissing boilers and the rhythmic clank of its gears, this grand creation would never taste the sky. Hiram Stevens Maxim arrived in Britain from America determined to conquer flight. In those days, the sky remained humanity's final frontier. Balloons had risen, gliders had been tested, but sustained, powered, heavier than air flight eluded even the boldest pioneers. Maxim believed his background in steam engines and mechanical design held the key. He envisioned a machine driven by a compact steam engine, powerful enough to lift a considerable load, yet light enough to cling to the air. To realize this, he assembled a dedicated team in Bexley Heath, southeast of London, where he acquired 20 acres of pasture land and erected a massive monorail test track nearly 300 feet long. The central challenge was power-to-weight ratio. Steam engines of the era were bulky and heavy, typically used to churn industrial wheels or propel locomotives. Maxim, however, refined the design to maximize steam pressure while minimizing mass. He commissioned a vertical water tube boiler able to generate steam at 50 pounds per square inch, feeding twin-cylinder engines that could produce up to 180 horsepower. When the throttle opened, steam hissed through copper pipes, valves clicked, and the flywheels came alive, turning massive two-bladed propellers faster and faster until they roared like startled beasts. The airframe itself spanned over 100 feet from wingtip to wingtip. It was constructed from spruce and bamboo, braced with steel wires and covered with varnished linen. Two sets of staggered wings formed a biplane arrangement, each wing curving gently at the tips to stabilize lateral motion. Beneath the wings, an elaborate undercarriage rode along the monorail, wheels enclosed in guide frames to prevent drift. At the front and rear sat elevator surfaces for pitch control, and twin rudders at the tails promised yaw stability. Every detail reflected Maxim's careful study of Lilienthal's gliders and Wenham's wings, yet he adapted those lessons for a steam-driven Leviathan. On August 31, 1894, the world's first steam-powered flying machine stood on its rails, ready for trial. A small crowd gathered, reporters, curious neighbors, even a handful of skeptical scientists. Maxim, ever the showman, donned his stovepipe hat and lit his cigar as his engineers fired up the boiler. Steam pressure climbed. Engines rattled. At full power, the craft began to move, creeping forward, then surging along the track. The ground trembled as the propellers carved through the air. Observers gasped at the pace, estimated at 30 miles per hour. For a fleeting moment, it seemed the impossible might be achieved, flight by steam. Yet as the machine gained speed, unforeseen forces took hold. The wings, designed for true flight through open air, encountered the constraints of the track. The monorail's guide frames prevented lateral drift, but without natural freedom, the craft developed stresses the structure could not bear. A catastrophic vibration rippled through the wings, and in seconds, the delicate framework splintered. Timber cracked, wires snapped, and the roaring engines ground to an abrupt halt. Smoke and steam billowed. Maxim signaled to cut the engines. The grand experiment had ended in disaster. Rather than retreating in disappointment, Maxim seized the moment to spin the failure into proof of concept. He argued that the monorail system itself had hindered flight, and that a free machine would soar unimpeded. He salvaged the engine, the propellers, and much of the framework, and returned to the drawing board. Although he built smaller models and conducted wind tunnel studies, he never again mounted a full-scale trial. Slowly, the world's attention shifted to lighter petrol-driven engines and smaller craft. The Wright brothers, across the Atlantic in North Carolina, were perfecting internal combustion engines that could lift a biplane into the air, and within a decade, they would claim sustained, controlled flight. Maxim's machine, however, fell into disuse. The hulking remains lingered in Bexley Heath, a rusting skeleton exposed to rain and wind. Local villagers scavenged its wood and metal, while curious onlookers marveled at its size. By the early 20th century, all that remained was legend, a footnote in the annals of aviation. Yet the significance of the experiment endured. Maxim had demonstrated that steam power, in theory, could generate sufficient thrust for flight. He showed the importance of structural rigidity and wing design under dynamic loads. He pioneered the use of high-pressure boilers and lightweight alloys, technologies that would resurface in later aeronautical innovations. Beyond technology, Maxim's greatest legacy was the vision of powered heavier-than-air flight as achievable. His project attracted public interest, inspired other inventors, and forced skeptics to reconsider the laws of physics. In scientific journals, his tests sparked debates on lift coefficients and propeller efficiency. In engineering workshops, his steam engines fueled ideas for marine and locomotive applications. Even after his machine lay broken on the rails, the echoes of its propellers continued to reverberate through laboratories and hangars across the world. Maxim himself turned back to his firearms business, patenting new machine gun designs that would see widespread use in conflicts to come. Yet he never relinquished his passion for flight. In private correspondence, he wrote of future projects involving electric motors and compressed air engines, an engineer eternally dreaming of conquering the heavens. He lived to see airplanes climb into the sky on petrol power. And although he never claimed the title of father of flight, his contributions laid crucial groundwork. Today, no pieces of Maxim's flying machine survive in museums. The once grand test track is grassed over, and a modest plaque marks the spot where the world's first steam-powered airplane nearly took off. Aviation historians sometimes lament the loss, but they acknowledge that the machine's fate underscores a fundamental truth. Progress often relies on brave failures as much as triumphant successes. In those moments when the engines roared and the wings trembled, humanity dared to dream of rising above its earthly bounds, and in doing so, took one more step toward the age of flight. As we look back from the perspective of jets breaking the sound barrier and rockets leaving the atmosphere, the steam-powered airplane that never flew seems almost quaint, a relic of a bygone era of steam and steel. Yet in the hissing of its boilers and the thunder of its propellers, we find a story of boundless ambition, mechanical ingenuity, and the relentless pursuit of dreams. It reminds us that invention is not a straight line from idea to achievement, but a winding path of experiments, setbacks, and persistence. And somewhere in that broken frame on the English moor, the echo of its potential still resonates, calling inventors onward to imagine and to build what has never yet been seen. Thanks for watching. On Lost Innovations, we uncover the inventions and ideas that could have changed history, but didn't. Subscribe to explore more forgotten breakthroughs and untold stories from the past. Like this video and leave a comment. How would our world look today if these inventions had been realized?